So we're talking about concavity. Concave up is where the graph looks like part of a happy parabola. Concave down is where it looks like an unhappy parabola. And we need to find inflection points, which is where it's going to change concavity. So it's going to change from concave up to concave down, or from concave down to concave up. Okay, so we gave you a graph here that the points were very nice and obvious to make our lives easier. So this here is -2, 0, -4, 0, and then this is -3, 2. Okay, so domain-wise, there's no restrictions, so we have all real numbers going on here. Our range is, well, you know what, I'm going to come back to that to just remind you how we do these things. Zeros, we have 2 of them. We could potentially have 4 with this graph, since it's an x to the 4th, but they hit at the double spots. Absolute max, there is none. Relative max is right here. That's the topmost part there. -3, 2. Okay. Absolute minimum, we have 2 of them. So our absolute minimum is both -4, 0 and -2, 0, because they are both at 0 there. And since our absolute min is at 0 for y and absolute max is none, we're going to go from 0 to infinity. So remember that your range comes from your absolute min and your absolute max. Okay? Relative min, we have none, since they are both the absolute minimum point. Okay, and then we're going to get into increasing and decreasing. By the way, if you need a reminder on how to do this on the calculator for a function, I will post the video that we had done before with that. So let's do a little line graph here. And remember, for all of these, we're going to focus on our x values. Okay, so we're taking our x values here. So I'm going to put them in order. I have -4, I have -3, and I have -2. And I'm going to look at, I'm going to throw those infinities in there also. I'm going to look at what I start doing. So from reading from left to right, we start by decreasing. So this part here is decreasing. And then I'm always going to switch back and forth between decreasing and increasing. And that gives me my little ranges. So I am decreasing from -infinity to -4. That -4 is not included because I am not increasing or decreasing at that moment. Okay. Then, if I stop decreasing, I'm going to start increasing at -4 until -3. And then I'm going to start decreasing again from -3 to -2. Don't forget your little u's here. And then I end up increasing from -2 to infinity. So to find our points of inflection, we are going to find the middle points here of our graph. These are our points of inflection. So we're going to average these two numbers together to get a point of inflection. And we're going to average these two numbers together to get a point of inflection. Okay, so pretty easy to average these two together since it's nice whole numbers, right? But just as a reminder, you could do -4 plus -3 and divide it by 2, which is going to give you -3.5. And in this guy, we're going to do -3 plus -2 divided by 2, which is going to give us -2.5. Okay, since it wants the points, it wants the coordinates, we are going to, if we had a graph here, we would substitute these values in to see where they fall on the y-axis. I'm going to kind of guesstimate for this one that they're at 1 because it looks like they are. Okay, if you were given a graph, that would be perfectly acceptable to just guesstimate them. But if you're given a function, substitute these values into the function to figure out the y values. Okay, so what's happening here is we're going to figure out where we are concave up and where we are concave down, and it's going to look like you're increasing and decreasing. It's written in that way. So we're starting off here till this point that is concave up. And then we start being concave down until our next point of inflection. And the last part is here. I've got a second piece that is concave up. Okay, so I'm going to write out those intervals just like I did for the increasing and the decreasing. So I'm going to put my numbers on top here, negative 3.5 and negative 2.5. And we are from here to here and here to here, concave up. And then between these two, we are concave down. Okay, so I start by being concave up from negative infinity until negative 3.5. Then I start being concave down from negative 3.5 to negative 2.5. And I end at negative 2.5 to infinity, being concave up.